to the Hwaseong site. And then line 12, line 14 is back in Kihyun. That used to be a parking lot. It was a very big parking lot, but we made a site over there. And then line 15 and 16, that's our newest line. I think you heard about how much it takes investment to build one line. It's a very big cluster. Actually is the largest semiconductor fabrication cluster in the world. We all have, as I said, 15 lines altogether right now. We are currently building line 16. So, normally, when you make fabs like Intel or IBM, they normally make 1 or 2 lines in one site. But in Korea, we have all 15 lines packed together as a cluster. This part. See this building? That's the building we are in right now. So you can like imagine how big the site is. Go over, start this way. All different kinds of wafers. They're all new products. CIS chips. That chip actually goes into your camera mode. My handset has a camera. They need chips to take pictures. That's what goes in my camera. And mobile AP, that goes into navigations right now. Hybrid HDD SOCs goes into hard disk drives. FRAM is a new type of memory, PRAM also, and 1N DRAM. That's all new high-tech products in the semiconductor industry.
These are types of chips that we have.
We know example in 1974. We joined by Inlay. We were actually acquired by Samsung Group and sort of like merged into Samsung Electronics. At that time, it was rather like making transistors, small transistors. And after that, there was a huge turning point. That was in 1983 and 1982. Sorry, that was when we started to make fabs in Kihyun, right here, where we are standing. And we made huge investments. There was a lot of worries that we were running out of money. But we overcame the difficulties, and after that, started to make money. Goes on. In 1993, 94, there was a huge shortage in memory, and the whole memory industry, had a very good time over there. Goes on, and we have different sites now in Austin and in China, Austin, Texas, United States. There's another package fab in Suzhou, China, and so on. Up to now. This part, I believe, capacity and precision, different divisions within semiconductor memory system outside and storage. This is little costume.
We'll take a look at this.
This is a model of a clean room. Clean room is
What used to be the
call it class 1. Normally clean rooms are class 10. Class 10 means within 1 square cubic meter there is less than 10 particles. Particle is a particle of dust. So if you say that, let's say in a football stadium, if there was a football stadium, the size of one particle would be the size of a baseball. So within this room would be less than 10 particles. That's a class 10 clean room. See all these people, they have masks, gloves, and also also headgear and stuff. That's all to prevent from particles to come out. Semiconductor is a very delicate instrument, and if you have particles floating around in the air, there's a huge influence on a lot of things can go wrong. I'll go over briefly how a wafer is made. This is 100% pure silicon. You put a rod in it and you spin it around and you pull it out, and it goes up to around 20 meters, 12 to 20 meters. It looks like a tree. It goes up and up and up, and you pull out an ingot of silicon. And then you chop it, slice it. And this is, yes, pure silicon with nothing on it. Semiconductors are called chips. We also call them semiconductor chips, and that was because the small size silicon wafers, see the ones over here, they look like chips once you eat. And then it grew bigger and bigger, and that's an 8-inch wafer, that's a 12-inch wafer. This one's an 18-inch wafer, that's the next generation. And it goes on. To make a wafer into a semiconductor, actually, you have to go through various different kinds of processes. Lithography, etching, diffusion, deposition, oxidation. Do this a lot of, we call them patterning, about 300 times. Each fabrication takes about, well, the short ones take 1 to 2 hours, long ones can go on to 8 hours of baking. And you go this way about 300 times, and a semiconductor comes out, wafer comes out. That's a mask. This acts like a film. So you put a mask over a wafer, you put light on it, put chemical on it first, and then you spread light on it. Some kind of chemicals respond to light, and they turn into different material. And then you put into metal inside those patterns. And you do that over and over again, and then that's comes out the semiconductor. And then we do the fabrication up to here, the Kyung and then we send it to another fab. There's another place called Onyang, one in Suzhou, China. And once they arrive there, you saw it into square chips. And then you put packages around it, and then you see the gold little threads that are coming out, they're called lead frames. Pull them out, and that's the actual semiconductor that you see in the market. And these are all different kinds of semiconductor wafers. There's a memory system inside, and this is storage. The patterns are different. Just notice that the patterns are different, the sizes are different. Also using chip parts. We also make hard disk drives and